Alright, you guys, so what we're going to do now, we're going to move into section 2.5 actually, but a lot of it's still kind of 2.4-ish. It's just that the right triangle situations are going to be a little crazier. So you can already kind of see that from the pictures that I've drawn here. So we're going to be solving some things. In this case, rather than solving for everything like we did in a right triangle, I'm just going to ask you to solve for the x that's shown in each picture. And again, it'll involve right triangle and some of the trigonometry that we're learning, and then get us ready for some of the word problems that we're going to see. So without any further ado, what I'm also going to do is do A and C in this video, and then I'll do B and D in a separate video, because the algebra is a little tougher over there, so I want to kind of wait for that. But in the first one, the first thing we have to do is kind of get a feel for, well, what exactly is x, right? I'm asking you to find x. And what x represents is this entire side right there. So what is the length of this entire side? So later we're going to learn some laws of sines and cosines, but knowing what we know now, the trick to this is to actually draw a line segment that is perpendicular to the side we're trying to find. And in this case, what this creates is a 52-degree angle and a 23-degree angle. And so basically what we're looking for, right, is how about we call this x1 and we call this x2. So the x we're looking for is the sum of x1 and x2. And so if I can find those, add them together, and we've got it. So the good news is the x1 is actually pretty easy to find, because for the 52-degree angle that we have, x1 looks like it's going to be the opposite, and this side right there, 100, is the hypotenuse. So finding x1 is not too bad. So x1, right, so if we're talking opposite over hypotenuse, well, that's my sine. So the sine of 52 degrees will be the opposite, x1 over the hypotenuse, 100. So multiplying both sides by 100, right, we end up with x1, right, being equal to 100, the sine of 52 degrees. So there's my x1. x2 is a little tougher, right, because for x2, we know the angle that it sits opposite of, so that's the good news, but I don't know any of the other sides. So the strategy will be is, why don't we go back up here? Now that I know that's 100 and I know that that is this 100 sine of 52, we could actually solve, let me even use another color, we can solve for that side there. And then once I have that side, right, as far as 23 is concerned, I would have its adjacent, and then that would be its opposite, and I'd invoke a tangent. So x2 then, for what we have to do, first off, is find this side. So how about I just call this, gosh, what do we want to call it? Let's just call it a y, for lack of a better phrase right now. So let's just call that y. So what is that side? Well, for what's given in this triangle here, right, my y value, right, is the adjacent. So my adjacent over 100 would equal to my cosine of 52 degrees. So multiplying both sides by 100, right, we'd end up getting that y is 100 cosine of 52 degrees. So now I know this side. So for 23 degrees, we know that the tangent of 23 degrees, right, is my opposite, which is x sub 2 over the y we just found. So my tangent of 23 degrees is equal to my x2 over 100 cosine of 52 degrees. Okay, and to solve for x2, all I would have to do is multiply both sides by this 100 cosine of 52. 100 cosine of 52. So what we get for x2, it's 100, the cosine of 52 degrees, and the tangent of 23 degrees. So there is my x2. And so we can now finally, right, what is x? Well, remember what we said at the beginning, x is my x1 value plus my x2. So putting this all together, x is 100 sine of 52 degrees plus 100 the cosine of 52 degrees times the tangent of 23 degrees. So there is your exact answer. Again, be ready to be doing that on actual quizzes, right? And in this case, we had to really string things together in terms of finding that value. In terms of an estimated value, right, as we saw in some previous work, what's nice about our graphing calculators, I can just literally type that line in. So we got 100, right, the sine of 52, parentheses, plus 100 times the cosine of 52, and then we got to multiply that to the tangent of 23. All right, so you can kind of walk through that. There's just basically my execution line, right? So it's just literally just rehashing what I already have there. Press enter, and it looks like it's equal to 104. Class rule, let's go 4 decimals, 93.44. 93.44 feet. Okay, so if this is 100 feet, right, this whole side together would be 104.9344 feet. And we pretty much have our value, both exact and in terms of a decimal. So again, you can see a lot of math. Where there was 2 unknowns, there's actually 3 unknowns, and so I had 1, 2, 3 equations, right, to basically piece this together. So hopefully some of our review, solving systems, doing some things algebraically can kind of help put this together, because it's what you need to get good at. Let me do C down here. The trick for C is very similar to what we just finished doing there. What I have here is a nice isosceles triangle, so x is equal to x, and as no surprise, these 2 angles are the same, and we're given the distance of this 100. And so to invoke my trig, I need a right triangle somewhere. So what I'm going to do is I'm going to basically, since this is isosceles, this line segment I'm drawing right there creates 2 90-degree angles. And so if we take a look at one of these situations, right, let me kind of put it off to the side here, right, this is 70 degrees. Here's the x that we're looking for, and then since we basically cut this in half, right, and again, I know it's cutting it in half because of the isosceles-ness of this, because of the equality, because of the symmetry going on. This line segment truly does cut this in half. The area on this side will equal the area on that side. So we truly have a half there. So that means this is 50 and that's 50. So there's 50 degrees right there, or 50 feet. So putting this together, as far as the sine of 70 is concerned, we know it's adjacent and we know it's hypotenuse. So that's a classic cosine. So the cosine of 70 degrees is my adjacent 50 over my hypotenuse x. And so starting to solve for this, I probably begin by multiplying both sides by x. We get x equals, or 70 degrees equals 50. Getting x by itself, I'll divide both sides by the cosine of 70 degrees. And there's your exact answer. So x, right, is going to be equal to 50 over the cosine of 70 degrees. So there's your exact answer. Of course, since these x's are the same, right, we've solved for both sides. To do an estimate, right, this would be in my calculator. I type it in like this. And to get the estimate, we'd have 50 divided by the cosine, in this case of 70 degrees, and it's 146.02. So 146.1902. If we go with 4 decimal accuracy. Alrighty, so there's basically that. Because of the symmetry, once I found that x, by default I have found the other x. We're good to go. So obviously you can see I'm still using right triangle geometry, still using opposites and adjacents, but because there's so much other things going on, we kind of have to piece the story together triangle by triangle by triangle. And of course these guys, right? There's a lot more algebra going on. So we'll cut to a new video, right, to take a look at those crazy situations when we get there. But hopefully things you're understanding, you're putting things together, seeing our relationships, writing those relationships in equations, solving those equations, and you should be able to come up with exact answers. Calculator comes later, as you see me doing. Exact answer first, and then estimate last. See you guys in the next videos.